Guys, today we are back in with another problem, and today's problem statement is count the smaller elements. Okay, so first I will write the problem statements. It is the count the smaller elements. Okay, so I will just highlight count the smaller elements. So basically what it is about is we will be given an array ARR. Okay, we are containing non-negative integers. That means it's a constraint that the integer values cannot be negative. Okay, so we will have non-negative integers. We have to count and return an array where answer. We have to return an answer where answer of I denotes the number of smaller elements on the right side of the array of I. Number of smaller elements on the right side of the array of I. And given time complexity to solve this problem in the question is n log n. Okay, so as we can see, before doing that, we will first check our inputs. Okay, so we have an input ARR array, which is an input array. In the input array, we will be having some elements 12, 1, 2, 3, 0, 11, and 4. Okay, and now what we have to do is they have given the output. There are 6 smaller elements right after 12. There is one smaller element right after 1, and so on. Okay, so first we will make a new array and then we'll return it in the new array. Okay, after selecting it. So it is nothing but we have to return the count of the number of elements which are smaller to the right side to the particular element. Okay, so I will write it like this, that when I'm doing this, I will be having a total array like this. Okay, so it will be easier for me to demonstrate the problem to you. So say for example new array. So in the new array, what the total number of elements after the first element. Okay, so my first element is 12, right? So after total number of elements which are smaller than my first element is 1, 2, 3, 4, 5, 6. So in the new array, I will put the count of the elements which are smaller than my first element as 6. Okay, now let's come to 1. Total number of elements which are smaller than 1 and which is present right to the right of this particular array is 2, 3, 0, 11, and 4. So if I check the value, only one value is there, which is 0. So I will put the count as 1. Now come to 2. What are the elements which are smaller than 2 to the right side? 3, 0, 11, and 4. There are no elements, only 0 is there. So I will put the count as 1. Okay. After that, I am coming to the value as 3. So only value is 0. So I will put the count as 1. Now I have count as 0. Is there any value which is lesser than 0 to the right side of 0? No. So if whenever there is no value, then I will put the 0 like this. Okay. After that, I am going to check 11. Only one value is there. So I will put it like 1. And again, we are coming to the last point where there is no value left and no value to the right which is smaller than 4. So I'm going to put a 0 over here. So this is my problem statement. And I'm going to return this particular new array. Okay, so now you will tell me, and we can solve this easily using brute force. So what is brute force basically telling us? That what we are going to do is we are going to take a pointer. Okay, we will start from here. Okay, and we are going to check from this pointer to I plus 1 till the end, from this pointer to I plus 1 till the end. If there are any values which are smaller than my ARR of I, then what I am going to return is I am going to put a counter as C. The counter is iteratively going to count all the values. Okay, the counter is going to check, okay, this is smaller, so update it. Again, the counter will run and it will check, okay, this is smaller, so update it. So similarly, what I can see is my count will become to a particular value. And when I receive the count at the end of that loop, I am going to again start another loop, create another array, and then I have to put the value. At the position of the particular index where the count, because for all values I have to put the value at, for 12 I am putting 6 at its particular index. So this is what I have to do. So in this case, it is going to take significantly long amount of time because the pointer will move from this direction and you cannot go in the previous direction, and number of multiple loops will be perhaps required. But yes, they have termed it as hard problem. This is not a hard problem initially. This is a slightly medium based problem, but it is a hard problem when they have said that the time complexity is n log n. So how we are going to do this? So we are going to do this with the help of a merge sort. So before diving into merge sort, I'm going to give you an example of how merge sort works exactly. So merge sort works like this, that we have to divide this array into two halves. Okay, so my initial half is 12, 31, 25, and 8, and my second half is 32, 17, 40 and 42. Okay, so merge sort means I have to sort this. See, if you see 12, 31, these are not sorted order, right? I have to return this in a sorted order. So while returning this in a sorted order, I have to follow some rules. So first is break it into two equal halves. Remember, you can make a note of it that we have to break the given array into two equal halves. When now we have broke the array into two equal halves, what we are going to do is we are going to further break the array. Okay, so if I further break the array which I'm going to get is 12, 31, okay, 25 and 8. So I can see my array will be looking like this: 32, 17, 40, 42. Now you will ask me, Arnav, what next? I have already break the array into again subdivided. Now you are going to again break the array into atomic parts. So these are like the atomic parts, means these are like the individual elements. Okay, so this is 25. You will have an 8 over here. You will have a 32, 17. You will have 40, okay, and 42. So this is the individual half. Now you will say, Arnav, what to do after dividing it. Now your task is to merge it. Again you will merge it, but this time be careful while merging it. So you're going to merge two values, 12 and 31. So when you're merging 12 and 31, it will be as it is. Okay, it will be as it is. Now you are merging 8 and 25. So how you are going to merge? 8 will come in front, 25 will come in the back. Okay, now you are going to do the same for this one. So 17 is going to come, 32 is going to the back. Okay, now you're going to do for this one. So 40 and 42. Okay, now my merging is complete. Now you will see, again, enough, this is done. Now what we have to do? This is still not sorted, right? Again I have to go and merge this. Now this time the 8 will come in the front, then 12, then 25, and then 31. Okay, I have to merge this. And now you will see, what with this? Oh, I have to do the same thing. So it's 17, 32, 40, and 42. Okay, so when I'm done with this, my task is to again merge it and make it a complete array with sorted values. So if I see my sorted values, my first value is 8. Okay, my first value will be 8. After that, I will get the lowest smallest value, which is 12. From that, we will get, after that, we are going to get 17. Okay, after 17, we are going to get a 25. Then we are going to get 31, 32, 40, and 42. So this is the algorithm behind merge sort. This is the algorithm behind merge sort, and this is how we are going to solve some set of values using merge sort. Okay, so this explanation was the merge sort explanation. Now let's come back to the code. And how we are going to solve our particular problem. So initially what we have made a class pair. Okay, so pair is nothing but pair will have two values, a value and an index. So it will have a value and an index. Okay, so what is value and index exactly? So if I see my case, I have 12, 1, 2, 3, 0, and 11 and 4. So 12 is lying at the 0th index, 1 is 1, 2, 3, 4, 5, and 6. So we have a value with a corresponding index. So we are making it a pair class which will have a value and an index. So this is nothing but a constructor of the class pair. Okay, now we are going to construct a lower array. So what is a constructing a lower array? So this is you can see this function is returning an integer array. So it is nothing but we are constructing an array where each element represents the count of the smaller element to the right. So this array is going to store the count of the elements. Suppose I'm over here, so I have to count over the elements over here, and I have to take a counter and it will update. Okay, it's like that. But it is going to update and return the array, total array. Okay, it will return the total array because our answer is like we have to return the thing in a form of an array. Okay, so this is the function, this is the driver function. You can check when you solve this problem. We'll be given an array from the user. We are taking the length of the array, we are storing it in the resultant array as the length of the array. Now we are taking the pairs array equals to new pair of nen. Okay, the size of the pair array is n. Now in the pairs array we will have index and a value. Okay, now we are going to sort it according to the index and the value present. That's the reason we are going to use merge sort. Now we are traversing it and filling up the pairs array. Okay, we are filling up the pairs array with the element present along with the index. So it's like my first element, if you see my first element is 12, 12, 1, 3, 0. So if I see my first element is 12, so my value is 12, my index is 0. Similarly, it will become 1, comma 1, and this will become 2, comma 2. Like this, my pairs array is going to be filled up. My pairs array is going to be filled up. After that, I'm going to apply merge sort. I'm going to apply merge sort to the pairs array, to the resultant array, with the starting index and the ending index. Now you will ask me, Anders, why we have put all these parameters. So this is 0 is the starting value or left value, okay, and n minus 1 is the last value or rightmost value. It's like binary search, we have all studied about it. So we are going to apply merge sort. We are going to apply to the array which we are going to sort. Now we are also having a resultant array because we are going to store everything in the resultant array, and finally we are going to return. So this is our main code, but this code is being backed up with the help of the merge sort function. So what do we have in the merge sort function? We are passing the pairs, so we have to declare the data type of the pairs array as pair, because we've already constructed. There's nothing called pair in the Java code. Pair has been made by us in the constructor. After that, we are putting a resultant array as well, where we are going to store the results. We have the starting point and we have the end point. This is our initial check that if the left is greater than equals to right, then we are going to return the array as it is. After that, we are going to divide the array into two halves. Okay. So what you can see is left plus right minus left by 2. We are dividing. Now we are going to recursively call the merge sort function. That's the reason it will traverse through it and sort it. So while calling the recursive function, we have pairs, result, left and mid. Now pairs, result, mid plus 1 and right. So what basically this is about? So when the thing is pairs, result, left and mid. So that means my start is equals to left, okay, and my end equals to mid. So that means if I have an array like this, and this is the medium position, I'm going to first start sorting. So the way I'm explaining you, this is the best explanation you can get, because I'm going to cover up all the basic stuffs. I'm going to cover up how you can visualize the functions, because these are the questions you will have and these are the doubts which will always come inside your mind, that okay, this is a merge sort, but in the merge sort, how we are having a mid plus, how we are having a left first and then mid. That means my start value, okay, and my end value, okay. So in my particular case, in this first case where merge sort pairs result left and mid, that means my start is left, okay, and my end is mid. So this is my end, okay. So I am going to just sort in between this area, okay. Now let's come to the next part. Result mid plus 1 and right. That means my end is right now, means the last value, and now I'm going to sort this part. And finally, you can see we have a merge pairs, result, left, mid, right. That means what I get is we are going to finally merge it and return the total sorted list. Okay. So this was all about this function. But if you see the last part, the first two parts are recursively calling each other, calling the main function, but the last part includes a merge method. A merge method is being made by us over here, okay, which has pairs, the resultant array where we are going to store the original array with the starting and index and the value, the left, which is the start, and the, if you see the left value, which is a middle value, which is the value at which the array is divided, and the right value is the extreme value. Okay. So we are passing all these things. Now we are keeping our n equals to right minus left plus 1. Okay. So this is our merge sort. This is our technique. This is our algorithms which are already made. Okay. So now we are having a pair temp. So in the pair temp array is like a temporary array which will store the value and the index of the pairs array. We are starting the index as left, j equals to mid plus 1 and k equals to zeros. Okay. These are loop counters. In the loop counters, what you can see is first we are traversing from I equals to left to mid, because I has initial value of left. J is equals to mid plus 1 to right. That means we are, if j is in the middle position, we are starting from here, the value next after the, just after the mid value to the end value. Okay. And now we are going to work. This is our while loop. Okay. So I'm assuming first I'm going to check my pairs of I value is greater than pairs of j value, then right count plus plus. What does right count plus plus do? As I already told you, if the value present at the index at where I am is greater than the value present at the right side, I'm going to count it. I'm going to use a counter. That's the reason we have a right counter variable over here, and we have to update it. Once we have to update it, now we have to we have to update the temporary array, which is going to store k plus plus equals to pairs of j plus plus. So basically, temporary array is now going to store the updated index. Okay, so you can see that resultant array is going to store pairs of I dot index plus equals to write count temp k plus plus and so. Similarly, if the value lies between lesser than equals to mid. Similarly, if my value lies lesser than equals to mid, then I'm going to update pairs of I of index plus equals to write count temp k plus plus. So in the temporary variable array, I'm going to do the same thing. In the case of the j is lesser than equals to right, means from mid plus 1 to right, we will have a temp k plus plus equals to pairs of j plus plus. Okay, so these are nothing but these are the pointers of the array which we are moving through. Lastly, what we can see is for loop is there from left to right, and in this we are going to update the pairs array in the temporary is equals to I minus left. So you can use this algorithm to this is the algorithm which we have written so that we can perform this action. But in most companies, you will not be having a merge sort integrated question. So this question can also be solved using an array list, which can easily solve this easily. We can also use it using normal arrays, using brute force. So based on the time complexity, merge sort is essential, and you also get to learn about merge sort. Okay, so this was all about today's problem, and I hope you like the explanation. I'm just quickly going to execute the code. So this is the code. Okay, you can just pause this section of the video. You can just scroll slowly and code it yourself. Okay, and this is all about the code, and we're going to submit it. So yeah, we have successfully completed the problem statement. Thank you, and we are looking forward to solve more videos.